See, okay, so what you have here is nice. If I were interested in comparing the job groups within the decade, that's useful. I think what I want to do, or what I would be intended to do, is what does the distribution of this guy look like for 1960, the 1960s, 1970s, 1980s, 1990s, 2000s? That's what I think. That's what interests me.
So could it be simple as, because I was trying to do a confidence interval for, you said to use
Probably one sample T. One sample Z assumes you know the population standard deviation. Which you don't.
So the reason why I was kind of like trying to concise it was because I don't know how I don't know how to put like any of the data into those.
First, you got to click over here, or click here, and it's going to give you a list. And you say, okay, I want this one.
So this should be like the total private normalized for the 60s. That's how I tagged it.
Okay.
Okay.
Or maybe you want confidence interval for all these guys. Just really select all. By holding shift.
Shift.
Yeah, it's like all. I mean, alternatively, you can just go.
Okay.
If you really want to name it that. Shift, hold that, select. And you can go hypothesis test, 95% confidence interval is fine.
Ah.
Here's all your intervals. Now, what have we learned?
Let's see.
So now, what you're doing here, this comparison, again, what it does is say, now in the 60s, because that's all we're doing, we're fixing the 60s, and we're saying, now as far as in the 60s, or 62 and to 1969, what can we tell about these, what can we tell about these confidence intervals? What have we learned? This guy's really relevant, this other case. We're talking about, another thing you could do is convert all these to percentages. You multiply all these by 100, and these would be all percentages. Really, I mean, it's effectively the same thing. Really, what it looks like is that it's kind of interesting. The problem with doing the confidence interval estimation, even after the data is scaled, you still see statistical differences. This guy is effectively saying between 25.5 and almost 28%. I'm 95% confident that the percent of jobs in the 60s in the private sector is between roughly 25.5 and 28%.
It should be, because private's like way.
Private's way up.
Right.
Okay. So and this one, but really, I mean, this is again interesting for me to compare within the 60s. But really, what I want to know is
Between the 60s.
I want to know between 60. So what I would like to see is N total private 60, N total private 70, N total private 80. I would like to see those intervals.
So how would I do it with what I have here? Would I just continue this trend, or should I just start a new worksheet and make it more simple? Because I feel like this is complicated. It's too cumbersome.
Yeah. So what I was advising you to do was create a new variable. So, for example, can I put it right here?
Sure.
Cut, insert columns. I'm going to call this one. So now what we're going to do is anytime we see, so now we can easily do some coding here. It's not really easy, but it's easy to do some coding. Coding, what's going to do is it's going to say, when I see certain values, put a certain value in there. So code data from, where's your normal, well, year is fine. Doesn't have to be normal. So year, store coded data in decade. And now what you're going to do is say when year is between 1962 to 1969, give me a value, decade of, I don't know, call it 60, or 60s, right? 1970 to 1979. Call that the 70s. Keep going.
Is it semicolon?
No, it's a regular colon.
Okay.
Continue that.
would it be?
2009.
2000.
Keep the process going. You can call that 100.
But you don't want 11. So throw out 10 or 11.
You can do that also. 2010. 2. All the way to, let's say, 2019. I know it doesn't exist in the data, but if it did, we could pick it up. 110. Good.
Okay.
And when you're ready, just hit OK. So decade's going to automatically populate. See how that goes. Now the nice thing is that so now we can use decade to split our stuff. Now, for example, suppose I wanted to create, let's just create a visualization before we use confidence intervals. Let's try box plot. So a box plot with groups, and my groups are going to be decades, right? So let's do my scaled, is n total private scaled already?
What do you mean?
Yes.
It's scaled?
Mm-hmm.
Meaning you already divided by the,
Oh, right, yes.
by the population. So it's been scaled, and we're going
Sorry, I
to
didn't mean to answer for you there.
That's all right. We're going to use decade to split it up by. Let's just do nothing else. Okay, the 60s, 70s, 80s, 90s. You can change these labels. But you see how I'm now able to compare across decades?
Oh.
Kind of cool.
Yeah.
Mhm.
We can do the same. We can play the same game with confidence intervals. Statistics. Same with sample T. Let's see if it lets us cancel. Yeah. Okay. So it's not going to be so nice. You're going to have to. You're going to have to do this by hand. So you're going to have to say. But here's an easy thing to do. You can go to data, split the worksheet, and say split n total private. Oops, sorry. You're going to split the worksheet by decade. So watch what's going to happen is you're going to get 7 different worksheets. One for the 60s. Now this only contains the 60s.
Mm-hmm.
And then you'll have one for the 70s, one for the 80s, 90s, 2000.
Oh, that's like
That's
that's
exactly what you did.
yeah.
So it does it for you.
It would have taken.
Yeah.
Oh,
See, the
man.
software has got a lot of neat tools. If you
You know how to use it.
Sure, sure. And it's a matter of just exploring it and